are looking at AMU2L3 today, so first let's get started with the new vocabulary. A graph is said to be continuous. If there are no breaks or holes in the graph. If there are breaks or holes in the graph, it is said to be discontinuous. Now there's three types of discontinuity that we're going to be looking at. The first one is infinite. And this happens when x increases or decreases infinitely as x approaches a from the left or right. So here's a on your x-axis. You see how the graph never crosses that? We could call that an asymptote, couldn't we? So this is where it is infinite discontinuity. Okay, the next type is called jump discontinuity. And this is when f of x jumps from one point to another once again at x equals a. So here is the point of discontinuity for a jump. The next one is called removable. And this is where there's a gap in the single line, when f of x is continuous everywhere else except for a hole at x equals a. Now let's try some examples. Example 1, we want to determine if the function on the graph is continuous. If not, we want to identify the type and the location. So we look here, this graph is not continuous from left to right. So where does it break? Well, there's a hole here and there's a break in the graph. So what is this point? 1, 2, 3, 4, 5 to the left. So it is no. This is a jump. And it is at x equals -5. Okay, example 2, we look at this graph and it continues all the way from left to right. So all we have to put on this one is yes. Okay, number 3, it is not continuous all the way from left to right. There's a break. And where is that break? Well, it's right here, because these graphs approach 1, but they don't actually go across it. So this is a no, it is discontinuous, and the type is an infinite because it goes all the way up and down, and it is discontinuous at x equals 1. Okay, let's look at number 4. This graph continues all the way from left to right, so all we have to do is put yes. It is continuous. All right, number 5. Where does this line not continue? Right here. There's a hole. So this is going to be no. And what kind is it? Well, it's a removable. And it is at what? X equals 1, 2, 3, -3. And number 6, is this graph continuous? No, it's not. And we have a double discontinuity here. So let's put no. All right, first of all, there's an infinite discontinuity right here at this line that never crosses it. That's the asymptote. So it is infinite at x equals 2. That's the point +2. Then we have a jump at what? X equals 1, 2, 3, 4. Okay, now let's look at end behavior. And end behavior is as x moves towards positive and negative infinity. So that is your x-axis over here. As it moves left to right, what happens to the ends of your graph? All right, there's only 3 choices. Either that graph will go up, it will go down, or it will approach some number, as in an asymptote. So if it goes up, the end behavior heads towards infinity. If it goes down, it heads for negative infinity. And if it approaches, we're going to put a number there. All right. So you see these two phrases right here? You are going to write those over and over because that is standard. That's how we describe each end behavior. This one is what happens as it goes to the right. This is what happens as it goes to the left. Now let's look at the sample graph over here and let's just see what it does. All right, as we move to the right, as we move to positive infinity, what does this graph do? It goes down, right? So as we move to the right on the x-axis, our graph, which is f of x, moves towards negative infinity. All right, on the other side, as we move this direction, what's going to happen to the graph? Well, it goes up, so it heads for positive infinity. Okay, so let's look at some examples here. And I'm going to start off on number 7. I'm going to write as x approaches infinity, f of x approaches, and as x approaches negative infinity, f of x approaches. Now all I need to do is fill in the blank. Okay, this part's going to be the same over and over. So let's look at our graph. What happens to this graph as x goes this direction? The graph goes up. So if it goes up, that's positive infinity. All right, now as x goes this direction, what does our graph do? It also goes up. So it approaches infinity. All right, once again, we're going to start with as x approaches infinity, f of x approaches blank. As x approaches negative infinity, f of x approaches blank. Okay, so let's look at our graph. As x goes this way, what does our graph do? Goes down, so that is negative infinity. Okay, as x goes this way, what does our graph do? It also goes down. So we have another negative infinity. So you're just describing the behavior at the end of the graph. Okay, now let's look at number 9. I'm going to start off once again by filling in the as x approaches infinity, f of x approaches blank, and as x approaches negative infinity, f of x approaches blank. Okay, so let's see what these graphs do. As x goes towards positive infinity, my graph goes up. So that is positive infinity. All right, as x goes towards negative infinity, what happens to my graph? Well, it's going down over here. So that's going to be negative infinity. Okay, and last, let's look at graphs approaching a certain value. So as x moves towards positive infinity and negative infinity, it's possible for it to approach a certain value but never cross it. All right, this is where you have those asymptotes, okay? So as x, if we look at our example, as x approaches positive infinity this way, what happens? Well, this is never going to cross this line. It just gets closer and closer and closer. So that's at negative 1. All right, let's look at the other side of it. As x approaches negative infinity, this graph is going to come up and never quite cross that line either at negative 1. So technically what you have here is an asymptote right there at negative 1. It's going to approach it but never cross it. So let's look at these examples. Okay, on number 10, we're going to start off with as x approaches infinity, f of x, which is your graph, approaches blank, and as x approaches negative infinity, f of x approaches blank. And this one I think is a little bit hard to tell. But as this graph gets closer and closer to the x-axis, it straightens out. And it appears to cross it here, but I think that is just a print error. It's actually not going to cross that x-axis again. So what we have here, as x goes towards positive infinity, the graph approaches 0, but doesn't quite cross it. And then we have the same thing as we're going to the left. The graph approaches 0, but it never quite crosses it. Okay, let's look at number 11. And let's get it ready again. As x approaches infinity, f of x approaches blank. And as x approaches negative infinity, f of x approaches blank. So let's see what happens. As x approaches positive infinity, what happens to your graph here? It's going to approach this line down here, but it's never going to quite cross it. So what is that line? 1, 2, 3. So it approaches negative 3. All right, now let's look at the other side. When x goes this direction, what is your graph going to do? It's going to come up, and it's also going to approach that line right there at negative 3, but never quite go over it. Okay, let's look at number 12. So we're going to set it up as x approaches infinity, f of x approaches blank. As x approaches negative infinity, f of x approaches blank. So let's see what's happening here. As x goes towards positive, this is going to go this direction, but it's never going to cross that line. So where is that line? It's at x equals 2. Now let's look at the other side. As x approaches negative infinity, what does our graph do? Well, it comes up, but it's never quite going to cross this line at what? Positive 2. Okay, let's look at number 13. Let's get it set up. As x approaches infinity, f of x approaches blank. And as x approaches negative infinity, f of x approaches blank. So let's look at our graph. And let's see, what is the graph? Now, all three pieces of the graph are the same thing. So as the graph goes to the right, what is the end behavior of the graph? This actually doesn't have any more behavior left to right. It just goes straight up. So we're not really going to worry about it. All right, let's look at this one. What happens as it goes to the right? It is approaching this line, but it's never going to cross it. So it's going to approach negative 2. All right, let's look at what happens when we go this direction. This one approaches but never quite crosses negative 2 as well. Okay, let's look at number 14, and let's get this one set up. As x approaches infinity, f of x approaches blank. As x approaches negative infinity, f of x approaches blank. So let's see, as my x goes to the right, what happens to my graph? Well, it goes down, but it never approaches. It approaches, but it never crosses the 0. Okay, as we're going the other direction, what's happening? Same thing. It's going to approach 0, but never cross it. Okay, the last one. Let's see what's happening here. As x approaches infinity, f of x approaches blank. And as x approaches negative infinity, f of x approaches blank. Okay, as our x approaches infinity, going this direction, what's our graph doing? Well, it's approaching this line but never crossing it, and that line is at 1, 2, 3, 4, 5. So it's going to approach negative 5. All right, now what's it doing as x goes this way? Well, it is continuing up. And you can see this never completely straightens out, so it's just going to keep going a little bit to the left. So we are going to say that end behavior is approaching infinity. And that is all for this lesson.